The first definition up is a sequence. A sequence is an ordered list of numbers derived from a pattern that can stop at any point or it can continue indefinitely. As you can see in the first example, the numbers are 2, 6, 10, 14. As you can see with the 3 dots at the end, the pattern continues indefinitely. With the second example, 3, 7, 11, 15, there's no 3 dots at the end, therefore it can stop at any point. Next, we're going to move on to the term. The term is just basically a value in a sequence. Now we're going to go back to the first example just to see, in a sequence, just to see how it's lit. 2, 6, 10, and 14. In the first example, 6 would be T2 because it's the second term. Now that's as simple as it gets. Next, we will be talking about the explicit formula. The explicit formula is a formula that represents any term in a sequence relative to the term number, where n belongs to any natural number, as you can see. The example I chose was A1, A2, A3, and then AN, which is just basically the number. The next definition up is a continuous function. A continuous function is a function that maps just real numbers, nothing else. So it can't be any negatives or any zeros or anything like that, and has a graph with no holes or jumps. As you can see in the example, I showed a graph with no holes or jumps. Next up is a discrete function. A discrete function is a function whose graph is made up of separate points that aren't connected, which just basically means, here, look, I'll show you a picture of it. There we go. It's a picture where the dots aren't connected. That's just basically what it is. Next up is the Fibonacci sequence. The Fibonacci sequence is a sequence of numbers where the sum is always the previous two numbers. So here's an example coming up right now. 1, 1, 2, 3, 5, 8, 13, 21. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8. That's all it is. After this, we have the recursion formula. The recursion formula is a formula by which each term of a sequence is generated or found from the previous term. As you can see, I showed an example of it. If you're a little confused now, don't worry about it. We're going to go over it. Like I said, I thought it was the hardest part of the whole chapter. It's a little confusing to understand, but it's just generated from the preceding terms. That's all you need to know for now, and one of my group members will go over it in more detail later. Now we have Pascal's triangle. Pascal's triangle is a triangle arrangement of numbers with 1 in the first row, 1 and 1 in the second row, where each number in the succeeding rows is the sum of the two numbers above it in the preceding row. So there we go, 1, 1, 1, 2, 1. So like 1 plus 3 would be 3, and then it's pretty simple. But if you don't understand it, like, again, someone in my group will go over it. Common difference. Common difference is basically as simple as it gets in the whole course, I thought. Common difference is the difference between any two consecutive terms in an arithmetic sequence. So as you can see in the example, 2, 5, 8, 11, 14, it goes up by 3 every time. Therefore, the common difference is 3. An arithmetic sequence is a sequence where the difference between the consecutive terms are constant. So let's say the examples was 1, 3, 5, 7, 9, then it's constant, so it's an arithmetic. Second example here is 3, 6, 9, 12, 15. So it goes up by 3 every time, Therefore, it's an arithmetic sequence. Now you know what an arithmetic sequence is. Now we need to know what a geometric sequence is. A geometric sequence is a sequence where the ratio of consecutive terms is a constant. So not the difference, now it's the ratio. So as you can see in the example 22, 11, 5.5, 2.75, it goes, you multiply each number by a ratio of half. Therefore, it's a geometric sequence. Common ratio. The common ratio is the ratio of any two consecutive terms in a geometric sequence. So if we use this example, what's the common ratio? The common ratio would be half. That's as simple as it is. Now we have a series. A series is just the sum of the terms of a sequence. So for an arithmetic series, the definition would be the indicated sum of the terms of an arithmetic series. Therefore, as you can see in the example, where we went back to the other one, it was 3, 6, 9, 15, the arithmetic sequence. Now we just add them all up, and that's your series right there. See, now we're going back to the arithmetic sequence. There we go. Now a geometric series. A geometric series is the sum of the terms of a geometric sequence. So now, I never showed this example before, but let's say it would be times 2, 2, 4, 8, 16. That's about it. Thanks for now.